Welcome to the course on cloud computing. Today, we will have our first lecture. So, as you might have seen the broad overview of the course. So, in this particular series of lectures, we will try to give a overall picture of what cloud computing is and what are its major components and what are the recent trends, and at the end maybe what are the different type of research opportunities or these trends of future trends in the cloud computing, right. So, before going to the details of cloud computing, we will try to have a quick overview of course and the basic paradigm of computing. Now, if you look at that as defined by ACM computing curricula in 2005, as they defined computing, it is a general way we can define computing to mean as a mean to solve any goal oriented activity, right. So, that means it can include starting from hardware software system for a wide range of purposes, and also making computing systems intelligent, using communications, finding, gathering informations from relevant to any particular purpose, and so on. So, if you look at it, has anything where some sort of a computing is needed, it falls under the computing paradigm. So, this gives us a broad spectrum of thing, not only in terms of resources, also in terms of the terms or category and level of people who are going to use it. Starting from a high end researcher or a professional to a student to even to a housewife or a citizen in general, want to use it for its benefit or something which serves particular purpose. Okay. Before going to other overview of this computing, I will just try to reiterate the type of course or type of things we will like to cover. So, initial lectures we will have a more things, most likely today and maybe something on the next day, that introduction to cloud computing, which has gives a overview what that NIST model says, what are the typical properties, characteristics, advantage and disadvantages of cloud computing, or role of open standards. So, how whether there is a standardization need of things. Then we will look at more as a cloud computing architecture, like what is the typical computing cloud computing stack, moving towards a service oriented architecture. So, what sort of service models are available in cloud, like typically infrastructure as a service, platform as a service, or software as a service, or anything as a service. Later we will see that anything as a service whether we can realize. What are the different deployment models, right, in case of a cloud, how when I want to deploy, whether it is in a what will be the different deployment models of a cloud. Then one of the another major aspect of cloud is the service management. Like as we whenever we try to purchase any service, or whenever I want to leverage any service, there is a need of service management, like from the say consumer end, I would like to have what is the guarantee of minimal services. From the provider end, the cloud provider or cloud service provider CSP want to see that maybe the profit, or maybe that how this guarantee, what are the resource requirement at the back end to serve so much computers. So, from the if you look at the provider consumer for any type of services, not only cloud services, any type of services in our day to day life, we require some sort of a agreement between the service provider and the consumer. What we say something called service level agreement, like I want to say that my availability will be 100% or near 100% based on my thing. Like I say, when an exam is going on, I want to have redundant services, so that the availability of the resources is 100% or very near to 100%. Whereas, when my practice session is going on, the requirement of availability may come down to 90%. Now, based on the availability, the resource pooling or resource management will be done by the at the provider end, and the provider will charge based on the type of his resources, type of availability, etc. Then there are issues of downtime, what will be, there are issues of quality of services, there are several other issues that we will try to discuss under the paradigm of service level agreements and other things. There is another important aspect is cloudonomics or economy of using cloud computing. it may not be whether it is always good that if I use cloud it will be beneficial, whether it is true. Like it is as we see, like suppose if you want to commute to 20 kilometer per day for your office or work, then it may be economical to purchase a car, right. But if you are commuting say even 50 kilometer or 100 kilometer once in a month, it may not be economical than purchasing a car, right. It may be more economical than hiring a car, right. Similarly, when I should hire, when I should purchase, whether there is a relationship, whether there is a economic model behind it, or what if at all, how do I from my say organizational point of view, maybe from a particular say event point of view, whether I can see that whether purchasing or hiring a resources or is economical, or what is the economic model of the things. So, that type of things, economics in cloud or economy in cloud, we have to see. Another aspect is the resource management, like this is more in the service provider end, right, or cloud service provider, how these resources will be managed, right. Like so what I see that I need to serve so many people. So, what sort of resources I need to manage at the things. This is true for anything, like if I say if I have a stationery shop or book which takes care of stationeries related to say academic things, like I say notebooks, pen and etcetera, etcetera. So, how much I need to stock, or it depends on how much maybe my sale projection etcetera. Or so I do not have a situation when I am starving for my store, or I should not have a situation when I am say my shop is full and I need to keep something outside the shop type of things, right. So, it is I should not have a overloading or unloading. So, I have a proper resource management. So, it is very tricky when we have a computing as a resource or when I provide computing as a resource, then I have to manage several type of resources. Like typically if I look at in a typical computing system, forget about cloud or anything. So, what are the things we are basically looking for? Maybe one may be the processor or the CPU popularly, or maybe or one may be the your working memory, or popularly the RAM or hard disk, and maybe network connectivity, and there are several other resources which are there, right. So, how much resources I need to maintain, manage, etcetera, right. So, any resources has a inherent costing into the things. So, if I need to manage huge volume of resources without utilization, then I have to incur what we say more cost on the resources or than in maintaining the things. So, this appropriate or optimally management of resources is a serious challenge, and they are here we would like to see that what are the different type of resource management issues in this particular cloud computing thing. So, other aspects of this cloud computing, one is the data management, right. So, data is a very tricky thing, like we look at this, how this data will be stored, managed, scalability and cloud services over this data services over that. If it is a not only data, if it is a databases and data stores. So, there is a separate type of looking at the data things in the cloud, and if it is a large scale data processing, then I need to look at the how this data management will be there. So, our conventional way of approaching normal data or database management systems, whether it is still good for cloud, or whenever I want to give as data storage or type of services. So, what type of things I need to do for the things, like we are popularly using different type of storage as a service stuffs, and in our day to day life, like one of the popular thing may be the Dropbox. So, how things at the background need to be managed. So, it is not like that I need to build a data services all the queries, but at least looking at that what are the architecture and what are the issues in data management type of things. Another major aspects of cloud is security, right. So, your data is in some other place, your computing in some others domain. So, what will be the different type of security aspects. So, it has like what will be the security which sub is a infrastructure as thing, or what are data related or storage related security, because data is a important aspects of our all things, like what many people say that you can regenerate a or reinstall an application, but you cannot reinstall your data. Like I write a report of 100 or 10 pages and it gets system get crashed, and then the data is lost along with the application. I can reinstall the OS, I can reinstall the word processing tool, but I can reinstalling the data is not possible, that particular report is not possible if not you have a recovery mechanism etc. Right. Whenever I have on my personal systems, like it may be personal computing desktop or in a laptop or wherever, then it is my responsibility to take backups or I have redundancy things in the things. But whenever I store the data into the other's place, then one is how things are saved and type of things in case of loss, or another typical thing comes up whether my data is being accessed or overwritten read by somebody else, right. So, that means whether this what is the security of this particular data. There are issues of identity and access management. So, this is another important aspects where particular identity and access management of the collaborating parties need to be there. There are issues of access control, trust, reputation, risk. So, there are several issues like how access control will be there, whether it is our standard access control mechanisms, whether role based access control mechanisms, or whatever things we work on the security. How much trust on having? I have a cloud service provider, whether I trust service provider 1 more than the service provider 2, or whether it is how to calculate a particular service provider. So, there are issues of the reputation, I want to look at a reputation. There are issues of risk of losing data, losing application, losing your, because your own customers, like you are purchasing cloud to serve somebody, right. So, you may in turn things. So, this trust, reputation, risk goes somewhere what we say 3 nodes of a triangle. So, they are interlinked, have a for any systems they have a lot of what we say a lot of influence on working of the whole systems, right. So, I need to assure that how it is assured in the cloud computing paradigm we will have to see. Then we will try to look at some of case studies or some what we say demo type of things on open source and commercial cloud, maybe some cloud simulator. There are various commercial cloud in things in the market. So, we will try to see that what are the basic property or how they work etc. Then there are open source cloud. So, we are trying to see that how a open source things are there. When we will if time permits we will try to see that what are the different step of installing a open source cloud, and there are a few cloud simulators also. So, we will like to, if it is time permits, we will like to see the simulator. And at the end of the things, as one of our major motivation of this academic world to take things in future, right. We want to see that something more in the future. So, we will try to look at the recent trend in cloud computing. So, those who are interested in research or even some of projects in PG level, UG level. So, they can have a pointers that what are the different aspects of trends in cloud computing. There are people are talking about fog computing and other different technologies. So, we like to see that what are the different aspects of those things. So, this is broadly the overall course structure. We will try to give a proper weightage based on the importance of the course, we will give more details as and when we will basically going through those lectures, right. So, with this we will try we will have a quick overview of what are the different computing trend which actually made this cloud computing a reality. So, it is not that it is from the day one something was there. So, it as we say that all invention or all any type of development is primarily come up with some necessity or requirement of the what we say community, scientific community, or even general citizen at large. So, that drives that what thing with there. One of the things there are definitely blue sky researches where it is driven by that in own things, but we would like to see that so much computing is already was in place or is in place. So, why still it has a importance, whether it is a totally new baby or new stuff, or it is a amalgamation or evolved through the things, right. So, what we see it is or in different literatures, or even one in if you look at the cloud computing as a whole, it is not a suddenly a new stuff which came into the play. It has evolved, and it has different other development which is already in place, which has basically helped in bringing this into play. So, if we look at that different type of computing paradigm which are or which were there for a long time and still still in a big it is there in a big way. So, one first of all the mother of the things, all those things is known as the distributed, or people say that it is a distributed computing, right. So, distributed computing, then we have different other computing. It is not that it came in the sequence like one after another, but it is more of the these are the different aspects what we look at the things. So, it is a distributed computing, we have grid computing, we have cluster computing, we have utility computing, and we are talking about cloud computing. Now, if we see that these different development where different needs, everybody has advantages, some disadvantages, and they helped in making some other things in a feasible way. So, we will go quickly because these are some of the things already known to you and are available in the literature, but just to have that why what is the how it came up this cloud computing maybe things. So, if you look at distributed computing, so, so we started with, or still we work with centralized computing, like primarily in previous days we used to use mainframe, where different terminals are there. So, jobs are submitted to the mainframe that gets executed and being used by the or being viewed by the user. So, primarily it is a something which is has a logically single processing thing, right. So, or what we say some sort of a uniprocessor computing or centralized computing type of things. Now, also in different places is there, it is not like that we need to throw out the things, there is a particular necessity of the things, and these are still useful in several places and being used at several areas. So, the other thing which evolved is the distributed computing, where you have different system distributed over a particular geographical space. Typically, it may vary from a lab type of scenario to a scenario where you have large geographical boundaries also. Again, it depends on the type of requirements are there, right. And one important aspects came up is that network link, availability of seamless network connectivity during between these collaborating systems, like they are what we say different network systems, right. So, it is basically a field of computing science that studies distributed systems. It was there for a long time. Use of distributed system to solve computational processes, right. There are different other type of other definitions which come up. If you look at the internet, several definitions come up. So, there are several, it is one says that there are several autonomous computational entities, each of has its own local memory. So, it is separate autonomous independent computing entities having their own local memories. The entities communicate with each other by message passing over a backbone communication network, right. So, that is one thing. If we look at the operating system point of or way of the concept, the processor communicates with each other through various communication lines like high speed buses or even telephone lines, where the things each processor has its own local memory, right. So, there are several type of example, people put different things in the distributed computing paradigm, starting from over internet networking is a distributed system, or this ATMs, bank machines, different branches of the banks, or even different collaborating and doing executing different functions, that can be a things. Intranet or work groups within the internet may be a distributed system. Computing landscape will soon consist of ubiquitous network connected devices, right, or rather not will be, it is already we have ubiquitous network connected devices. So, or what we say, it is something ad hoc type of establishment which comes and type of things, and these days we see different type of networks which form as ad hoc network. They are different volatile, like one example is vehicular ad hoc networks, right, like vehicles, smart vehicles with their own onboard units, communication path. Once they come together, they form a ad hoc network, and it executes different type of functionality, like maybe safety related things, maybe entertainment related or infotainment related type of things, and different type of stuff are there. So, if you look at the broad type of computers in a distributed system, so they are primarily what we say workstation, server systems, and personal assistance devices, like it may. So, workstation is computers which are in the end user to perform computing, server systems which works on a which gives some provide some services per se. So, computers which provide resources and services, right. There can be personal assistant devices like handheld computers connected to systems via wireless communication network. It can be any type of things, like any type of communication paradigms which helps in communicating with the things. So, these are the different what we say typical end nodes in a distributed systems, right. There can be other type of nodes also, like which has more network capabilities, network processing type of things, etc. But this what we can say broadly, these are the typical nodes in a typical distributed system. So, if we look at the why such of things, some common properties or common advantages or what we say benefits of distributed system. One is fault tolerant, like you have one or more means several systems are working. So, even with some node failures, it works faithfully, right, or maybe at a lower performance, but it is not totally out of service, right. Had it been a centralized system, so if down, the whole thing is down, but you get to do something in a lower thing. So, it also to make it fault tolerant, there are different mechanisms, etc., many of you may be knowing, and to make the things. So, there are other things that each node, another typical aspect is each node play its partial role, right. So, each node in the distributed system plays its partial role. There is another aspects of or a property of resource sharing, they share resources among themselves. There is a load sharing. So, what is not only resource sharing, that is computing resource sharing, but also load sharing, like if it is a load, or what we say that load balancing among the things can be realized, easy to expand. So, usually systems may be like that we can easy to expand, like I can have I can add distributed system more system into the network as and when I have it or use it. Performance is a issue. So, parallel computing can be considered as a subset of a distributed systems where I can have higher performance and need to be monitored. So, what will so another aspect of distributed system is that why we require, maybe the nature of application demands it, maybe the different performance, like I have computing intensive, data intensive type of things, and in some of the cases I require a robustness into the system, that should be no single point failure. I do not want any single point failure. I may be doing a mission critical things which may not be very computing intensive or memory intensive, but I can't afford to do any failure on the system, right. So, in these several cases there is a need of the things, or in other sense this need primarily one of the primary what we say motivation of developing or development of these distributed systems. So, we will break for now, and we will continue our discussion in the subsequent in the next lecture. Thank you.